All right, guys, so we're back for the second half of graphing trig functions. So we've already done sine and cos, and their reciprocal functions, cosecant and secant. So today we're just going to do tan and cotan. Okay, so let's start with the tangent graph. And we'll start with the tangent graph by doing the sine relationship over the cos. So let's do tan of x equals y. Okay, so if we're doing the tangent graph, remember, we're plugging in, this is sine, it's the same as sine of the angle over cos of the angle. So kind of keep that in mind as we're graphing. Okay. So for the parent function of tangent, let's see. Well, if I was on the unit circle and I was at 0 or 1, 0, and I did the tangent. Remember, tangent is to take the sine, which is technically the y value, over the x, which is 1. So I'd have 0 over 1. Well, 0 over 1 would still be 0. So tangent is at equilibrium at 0. Okay, we're actually going to use the pi over 4 because it's easier. It's a nice number. So what's the tangent at pi over 4? 1. So pi over 4, I'm up at 1. If I go all the way to pi over 2, then I'm 0, 1. And if I try to do 1 over 0, 1 over 0 is undefined, and that creates that vertical asymptote. So there we're introducing our first vertical asymptote. Okay, and then we could keep going around the circle. So if we keep going around, the next pi over 4 would be 3 pi over 4. That would be here. And that would be 1, except you would have a negative x, so it would end up being a negative 1. So then I'd be down here at negative 1. Okay, then if I went here, I'd be negative 1, 0, which if I do y over x is 0 over negative 1, so that's still 0. So at pi, I'm back up to 0. At 5 pi over 4, I end up being negative over negative, which ends up being a positive 1. And then when I get down here to 3 pi over 2, I end up having a 0 on the bottom if I do y over x. So I end up with another asymptote. Okay. Now, these are some of the critical points. I'm going to do a couple backwards. So I'm going to go negative pi over 4, negative pi over 2. I'm going to go ahead and fill these in just for the sake of it. You could go and do those again on your own. If I go to negative pi over 4, I end up with a negative 1. Okay, so the graph of tangent ends up looking like this. You have this nice smooth curve that's increasing towards that asymptote. On this side, you are concave down. If you haven't heard of concavity before, concavity of a graph is how it opens. So like your graph would be concave up or concave down. So I think of it as a bowl. So if you think of a bowl, the way that a bowl is shaped, if your bowl is facing upward, this is concave up. If you think of your bowl as facing downward, there's your little inside of your bowl, this is concave down. So when I look at a graph, like right here, see how this is curved as if the bowl were facing up? This is concave up, whereas this bowl is facing down. That's concave down. So when you're drawing it, use that to help you. And it has this point, this is called a point of inflection when it changes, is right there. So this guy is concave down that whole time. And it can be, depending on how well you've graphed it and how nice and even your graph is, it can be easier to make it look concave, but it should be curved. Okay. So what we notice here is that this graph is definitely periodic, meaning it repeats itself, right? It has a certain period over which it repeats. But that period is not 2 pi. In fact, that period is just from asymptote to asymptote. So the period for tangent is not 2 pi. It's from negative pi over 2 to pi over 2, which is pi. So that is new. That is brand new. Okay. And for tangent, you could graph, like if you wanted to graph a period, guys, you could just graph from here and then do the asymptote and then go to here. That would technically be one full period. But for tangent, we really like to see that whole asymptote to asymptote part of the graph. So that's going to affect how we graph tangent when there's transformations. The way that we're going to graph it is we're going to graph that beginning of that 0 line, right? The phase shift, which I'll talk about later. And then we're going to go half the period forward to the asymptote, and we're actually going to go half the period backwards. And then that will give us a full period. So a tangent is unlike any other trig function that you're going to do. Even cotangent is not like this. You're going to move this critical equilibrium value, and then you're going to go half the period forward and half the period backwards. Okay, so what's important to note? We have an asymptote that happens halfway through our period forward and halfway through our period backward. We have a critical high value of 1 and -1, and those occur halfway between these. So you still have your graph broken up into fourths. So like here's your first, fourth, second, third, fifth, first, second, third, fourth, fourths. So we still have those like 5 critical points, if you will, but sometimes the critical points end up being asymptotes. So here we have asymptote, asymptote, and then these 3 critical points. The domain is definitely going to be affected because we have asymptotes. So let's see if you remember how we did that the other day. We would say all reals except, pick an asymptote. I'm going to pick pi over 2. And then you're going to have to say how often it repeats. So it repeats however long the distance is here, which for tangent is the period. So in this case, it's going to repeat every pi n. And then you're going to say n is an integer. Range is the easy one, because range is all reals, or -infinity to +infinity. Okay, so now let's try some transformations with this and see how well you really understand it, okay? All right, so let's do, I'm going crazy. You know how I like to just bump it up a notch. So this time, you know what? I'm going to call it f of x this time. Why not? Let's be nuts. So I'm going to call it 3 tan. We'll do 2x minus, I'll keep it fairly simple, 2x minus pi over 3 plus 1. Okay, so you're going to attack this the same way we did sine and cosecant and secant, which is you're going to figure out what a and b and c and d are. So first, let's factor out our 2. So we get pi over 6. Oops, I don't need the plus 1. Okay, so then I would locate A, B, C, and D. So A is 3, which affects my vertical stretch. B is 2, which affects my period. Now be careful, folks. The parent function period for tangent wasn't 2 pi, it was pi. So instead of 2 pi over B, you're going to do pi over B. So there's my period. My phase shift is positive pi over 6 to the right, and then up 1. My step, which is still important, is a fourth of my period. Ooh, I guess this one isn't nice. A fourth of my period would be pi over 8. So these guys all need to match. So again, I think the easiest thing that they go into is 24. Sorry about that. So this would be 3 pi over 24. This would be, my phase shift is 4 pi over 24, and my period, is 12 pi over 24. Okay. Okay. So let's get our graph ready. Normally, I would say we would start with our x-axis, and we will, but there's one thing that's going to change. So the first thing is I'm going to go my phase shift. That has not changed. This is where I'm starting. So I'm going to go positive 4 pi over 24. So 1, 2, 3, 4, these little guys. That is my beginning of my period. But remember, guys, for tangent, we're going to take this guy and we're going to go half the period forwards and half the period backwards to an asymptote. So instead of just counting all of your period forward, you're going to go half of this forward and half of it backwards, and it will hit the asymptotes. So half of this would be, instead of 12, I'm going to go 6. So 1, 2, 3, 4, 5, 6 would land me at 10 pi over 24, and that's an asymptote, note to self. So I can go ahead and put that in. And then I'm going to go back half the period. So 1, 2, 3, 4, 5, 6, which is negative 2 pi over 24. Okay. All right. And now let's do our y-axis. So our y-axis, normally my equilibrium has been shifted up to 1. So I still need 1. That's my new x-axis line, if you will. Right. And then your amplitude is going to affect your critical high and low values, which used to be 1 and -1. So I'm going to go up 3 just like before to 4 and down 3 to -2. Those are now my critical highs and lows. I'm not actually going to use the horizontal lines, and I'll show you why in a second. So when I go to graph tangent, tangent, you moved, remember we moved the phase shift, and the phase shift should have been 0. So we're going to, when we move our little phase shift, we should be right on our equilibrium line, which for this one was 1. Okay. Halfway from here to the asymptote, halfway in between, you're at that critical high value, which used to be 1. But now halfway in between, which again, this was 6, so I go 1, 2, 3, or a step. So 1, 2, 3, halfway in between, I should be at my new critical high value of 4. And then halfway in between this direction, I should be at my critical low value, which is now -2. So see how I got that? Started with my equilibrium. Halfway between these two, I was at my critical high. Halfway between these two, critical low. And then you're doing your best to kind of have that concave up and concave down. Okay. So you could give me all these coordinates if I needed them. Remember, because you could use your axis to help. Let's do domain, all reals, except we got to leave out those asymptotes. I'm going to go for this one. This asymptote is, if I reduce it, and I should, would be -π/12. And then let's see, this distance, remember, this is just the full period. So if your period is π/2, then you're just going to go π/2n, or n/2. Don't forget to tell me that it's an integer. And then your range, careful, this time it's f of x, is all reals. Okay. And if it was a negative tangent, what do you think you would do? I'll keep this one easy. -4 tan x minus π/3 plus 3. So b hasn't changed, so that means your period is just going to stay pi. My phase shift is π/3. You know what? Let's make it plus. So it's going to be -π/3, and my d value is 3. My step is 1/4 of my period, so π/4. So I'm going to have to change everybody into 12ths. Okay. Okay, so if I was graphing this guy, let's see what we got. So first we'd go our phase shift. So I'd go 1, 2, 3, 4. -4 π/12 is equilibrium. For tangent, you're going to go half the period forward and half the period backward to get to an asymptote. Half my period would be 6 π/12. So 1, 2, 3, 4, 5, 6 would put me at 2 π/12, and back 6, -10 π/12. Okay, and those are asymptotes, so might as well put those in now. Okay, y-axis, I went up 3, so I'm going to go up to 3, label that. And then my critical high is going to be 4, my amplitude up from that, 1, 2, 3, 4, 7, and down 4, -1. Okay, that phase shift should be your perfect equilibrium of 3. If it's a negative tan, then your graph is just going to be reflected over the x-axis. So halfway in between this direction, instead of being at the critical high, you're now going to be at the critical low. So halfway in between these two, I'm now at -1 instead of up at 7. And then it flips on the other side. I would be at my critical high over here. And then again, I'm going to do my best to make it that nice, smooth concave up and then concave down. You'll get better at it as you go. Domain, all reals for x, except, let's see, I'll pick this asymptote. Again, it doesn't matter which one, and that would reduce to π/6. It happens every full period. The period was pi, so every πn or n pi, it doesn't matter the order there. And then, of course, my range is y is all reals, or -∞ to +∞. Okay, so that's tan. Tan is the harder one. So now let's look at cotan. Cotan is easy because you don't have to do that like half forward, half backward business. And cotangent is literally the reciprocal of tan. So if we think about it like that, if we think about the graph of tangent, so I'm going to imagine that I'm doing tan of x. Okay, if I was doing tangent, I would have a 0 here. I would be at 1 at π/4. I would have an asymptote at π/2. I'm just graphing those critical points. Then I would be at my critical low of -1 at 3 π/4, and then I'd be back up to 0, right? That's for tangent. But here's the deal. When I do the reciprocal, If I do the reciprocal of 0, what happens? Because remember, these points are for tan. If I reciprocate 0, I get an asymptote because I'd have 1 over 0. So that now becomes an asymptote. And any asymptote would actually become a 0 because remember, that would put the 0 on top. So I'm going to get rid of this guy and put a 0. So the tangent has 0. We said if we reciprocate 1, that's still 1. So that guy stays there. And if we reciprocate -1, we still get a -1. So that guy stays. And this 0 becomes an asymptote. So there we go. I just went from tangent, which was the black points, to cotangent, the red points. So let's see what's the same and what's different about this. Well, first of all, tangent, if it's positive, was an increasing function, as you noticed. And the cotangent is a decreasing because it's flipping. It's doing the reciprocal action. What we also noticed, and this is what I was talking about, is that you don't have to like go forwards and backwards. From 0, cotangent starts with an asymptote, goes the full period, and ends with an asymptote. So there's no more of that half forwards, half backwards business. You can just go straight forward. So that's really cool. Okay, otherwise everything else is pretty much the same as tangent as far as graphing it goes. So let's do it. F of x equals, let's do 5 cotan 3x minus 2 pi minus 4. Okay. If you want to pause this and try it, you could. I'm going to go ahead. Factor out my 3. I get minus 2 pi over 3. A is 5. B is 3. Now remember, the period for tan and cotan is only pi, so you're only taking pi divided by 3. My phase shift is 2 pi over 3 to the right, and I'm down 4. My step is 1/4 of my period, which would be pi over 12. So unfortunately, everybody needs to be put into 12ths. Okay. All right, so here I go. I'm actually going to do this. Okay, so I'm going to do my phase shift first, which is 8 of these. And then remember, I don't have to do the half forward and half back because this is an asymptote. Cotan always starts with an asymptote. And then it goes the full period, which only happens to be 4 of these. So 1, 2, 3, 4. And that's the end. The end of the period is also an asymptote for tan, or for cotan. Okay, let's do our y-axis then. Oh, I should have marked this, sorry. So this was 12 pi over 12. Okay, so then my y-axis, I went down 4. And then up and down 5. Okay, so those are my new critical high and critical low. So let's do it. All right, halfway in between here, it should be at equilibrium. So halfway, I'm going to go down to -4. Again, if you want to use those guidelines, you can, to just really make sure that you're doing it perfectly. So if you wanted to, you could have your little line here, your little line there, your little line there, just to kind of help you line things up. Cotangent is decreasing, so it has the critical high in that first little section. So halfway between these, which is at 9 pi over 12, I would be up at 1. And then over here, halfway between at 11 pi over 12, I would be down at my critical low, -9. And then again, as best as I can, it's hard, I know, to kind of give it that curvature, but you kind of want to have it curve as much as you can. Okay. All right. So it does look like this, even though it's kind of hard to see, right? It's got that concave up part first, and then that inflection point, and then a concave down. Okay, let's do domain and range. Domain, I'm outside recording, so if you can hear this bird going, sorry. I want all reals except x cannot be. Asymptote, I'm going to use this one, but reduced, which is 2 pi over 3, plus it takes me the full period, which is pi over 3, to get to the next asymptote. So pi over 3n, n is an integer. And my range is, oops, not y equals. My range is f of x is all reals. Okay. All right. That's basically it, guys. I could do another cotan. If it was a negative cotan, you would have your low first and then your high. That's the only thing that would change. So you kind of just need to practice graphing these. In the next unit, we're going to go do a lot of going from the graph back to writing the equation, but that'll be in the next unit. So we'll see that then. Okay, I'll see you guys in class.